Everyone, my name is Marvin Sendi Kadiwa, and this is my project where I analyze the water quality on the different samples in the region of Uganda. So this is the material links. So all the code has been submitted on GitHub on this link, and the presentation is on this YouTube link. So okay, before we dive into the visualizations, let me first walk you through the raw data. So this is the raw data that I used to come up with those visualizations. So we have the source name, village, parish, as well as other values such as the turbidity of the water, the color, the electrical conductivity, the calcium hardness, nitrates, and other fields. So all this data, I'm going to be presenting it in visualizations in a smarter way. Okay, so on to the bar chart. So I came up with a number of bar charts, and so this first bar chart, it shows the ammonium concentration per source name. Now, remember, there are 187 water sources, and we are only interested in the ones that have the highest ammonium concentration. So I picked up the top eight water sources and ordered them in terms of ammonium, and ordered them by ammonium concentration. So we can see that Resource Center of Busoga University has the highest ammonium concentration, followed by Shallow Well at Prison Mosque, and followed by these others. So we can already see that these are the sources that we are interested in. Then I also viewed electrical conductivity per water source, and we can see that Mawuta borehole has the highest electrical conductivity, followed by Zero Masjid, and yes, followed by these others as well. So I also created one for the pH level. Now, for the pH level, we have two. So we are interested in water sources that have the highest pH level, which would mean their water content is slightly acidic. And then we are also interested in the other way around, where we have the lowest pH concentration, meaning that water source is alkaline. So this is the one for where the water sources have the highest pH concentration, meaning they are acidic. So zone 7, block 8, this water source, it had a pH level of 8, and these other water sources had a pH level of also around 8. So we can already see that water from these regions is acidic. Then still on the pH, but reshuffling, but ordering in ascending order, meaning we have the water source with the lowest pH, or the most alkaline water, as Bulonda Protected Spring. So it has a pH level of 4.7. So the average pH level is 7, and anything below is alkaline, and anything above is acidic. So we can see that these water sources, their water needs to be neutralized. And then okay, on to my next visualization. So this is a pie chart where I viewed the different metrics per district. So these metrics are averaged. Okay, so for example, ammonium concentration. So this is the average ammonium concentration in Iganga. We can see that it's higher than the others. Okay, so it's easy to follow up on why Iganga water has the highest ammonium concentration. Then in terms of pH, you can see that they are all around the average. That is they're all around the average. Then the turbidity, we can see that Lamu water has the highest turbidity, so meaning this water is kind of dirty-ish. Then the total salinity, so we can still see that Lamu water. So we can see that Lamu water is standing out in different metrics. So meaning that amongst all these 17 districts, Lamu water has potentially one of the unhealthiest water, one cleanest water. Then can see total hardness, still Lamu stands out electrical conductivity. So electrical conductivity, you can see that LAMO is still standing out. Even dissolved solids, LAMO water. So we can see that LAMO water is one of the dirtiest. Okay, in terms of chloride, okay, chloride, we can see Kayunga has the highest. Phosphates, we can see Ginger has the highest. Nitrates, sodium concentration, we can still see LAMO water. Then potassium, we can see Iganga as one of the highest. So from this pie chart, we can gather insights that LAMO water is a bit unclean compared to the other regions in more than one matrix. Then onto my final visualization is a scatter plot. The scatter plot shows relationship between two independent variables. So I built a variety of scatter plots, but only these two stood out. So I have a scatter plot which shows total alkalinity content vis-a-vis pH. So we can see that as the pH increases, the alkalinity of the water also increases, or even the other way around. So we can see that these are kind of dependent variables. And then I also came up with a scatter plot for electrical conductivity vis-a-vis pH. We can still see the same relationship. As pH increases, electrical conductivity increases as well. So, okay, that makes my final visualization. Now onto my code. So I submitted this code on GitHub, as I mentioned earlier on. So this is the code for my pie chart, and this is the code for my bar plot, still submitted on GitHub as well, and for the scatter plot. So thank you very much. That's it.